So today we're looking at parametric differentiation. Okay, now the way this works is we need to differentiate in terms of y. So differentiate y in terms of t and differentiate x in terms of t, and then we need to kind of bring them together. So here we'll notice this formula. Now this here is the kind of the key formula here, but what we're actually looking at is, so this is the key formula, so get this one down. I'll just give you a second to get that down. But actually, the one that we use the most is this one here, dy by dx. Now this comes from, you can think about KFC if you want, keep, flip, change. So dy by dx, I'm going to write it over here. Dy by dx is equal to dy by dt times by dt by dx. Now you can see that if you were to do this, you can just cancel those dt's and get dy by dx. Ooh, made a mistake there. It should be dt by dx, sorry. So just get that down. I think this one's probably here's the most important one. That's the one we'll probably use the most. Okay, we're going to get this one down here as example 1. So find the gradient at the point P where t is equal to 2. So now they've given us this parametrically, so they've given us x in terms of t, they've given us y in terms of t. So what we need to do here is we need to differentiate x in terms of t, differentiate y in terms of t, and then once we've done that, we can use the formula which we wrote down up here. So let's do this first one here. So if I differentiate this in terms of t, we're going to get dx by dt is equal to, well, this is going to differentiate to 3t squared. T just differentiates to 1, so I'll leave that like that. And I might as well, while I'm here, differentiate this one. So dy by dt is equal to, well, 2t differentiates to, sorry, t squared differentiates to 2t, and the 1 just differentiates to 0, so we're just left with that. So this here are the differentials of dx in terms of t, dy in terms of t. But we don't want that. We want the gradient of dy by dx, the gradient of the curve. So if we want the gradient of the curve, what we really want is dy by dx. So we know that dy by dx is equal to, from that formula up on the top right, dy by dt times by dt by dx. So the only thing we've got to do here is we need to, I'm just going to bring this down a little sec. We actually need to do the reciprocal of this top one here. So we don't want dx by dt, we want dt by dx. And this is equal to 1 over 3t squared plus 1. So then when I'm actually doing this, dy by dt is equal to 2t times by dt by dx is that 1 over 3t squared plus 1. So in which case this leaves us with 2t over 3t squared plus 1. Now this is just our this is our gradient of the gradient of the curve in terms of t. Okay, so we want to sub in now 2 to find out what that is. So at t is equal to 2, which is when we want it, we end up with dy by dx is equal to 2 times 2 all over 3 times 2 squared plus 1, which is equal to 2 times 2 is 4. Let's see on the calculator. Fraction button, 2 times 2 all over 3 times 2 all squared plus 1 is equal to 14 over 3. Like so. Well, I'll give you a second to get that down. Okay, let's have a look at this next one then, example 2. So, with this one here, we're now differentiating. We need to, again, do exactly the same. Differentiate x in terms of t, or theta in this case, sorry. Differentiate cos in terms of theta. And then we're going to use that formula, which is dy by dt is equal to dy by dx. Yes, it is. Sorry, I made a little mistake there. I copied down on my calculator, haven't I? I said 4 over 14, but I wrote 14 over 3. There we go. Perfect. Sorry, I think it's because I was thinking about the next question. So with this one here, we're differentiating in terms of theta this time. And again, we need to differentiate dx in terms of t, dy in terms of t. So let's do that first of all. So, I think you'd probably be able to do this yourself actually. But I will have a little go at it. So, dx by dt is equal to, now I always draw the little sine, cos, minus sine, minus cos, and we're differentiating, so we're going this way around. So I know that sine differentiates to cos, so this is going to be equal to 3 cos of theta. Cos differentiates to minus sine, so dy by, oops, just realised I made a little mistake there. So this should be dy by d theta, sorry. So dy by d theta is equal to, well, cos differentiates to minus sine, so that's minus 5 sine of theta. Now remember, we don't want dx by d theta, we want d theta by dx. So we need to do the reciprocal of this, which is d theta by dx is equal to 1 over 3 cos of theta. So if I want dy by dx here, so dy by dx, using a very similar formula, is equal to dy by d theta times by d theta by dx, which is equal to, dy by d theta is minus 5 sine of theta times by d theta by dx, which is the 1 over 3 cos of theta, which is going to leave us with minus 5 sine theta over 3 cos theta, which is equal to minus 5 over 3 tan of theta. Now remember, it's not asking for us to find dy by dx, it's asking for the parametric equation. Sorry, it's asking us for the normal at the point P. Now to find the normal, we need to do the reciprocal of dy by dx, subbing in the value pi over 6. So let's first of all find the tangent. Make it nice and clear. This is the tangent. Tangent is dy by dx, which is equal to minus 5 over 3 tan of pi over 6 in terms of radians, so that's equal to shift mode, I'm already in radians, that's good. Fraction button, minus 5 over 3 times by tan of open bracket shift pi over 6 close brackets, which is equal to, as a whole number, minus 5 root 3 over 9, which makes sense. Minus 5 root 3 over 9. So if I want the gradient of the normal, we know it's going to be 1 over this. So 1, we need the negative reciprocal, don't we, as well, sorry. 1 divided by my answer is equal to 3 root 3 over 5. But don't forget, it's the negative reciprocal, so this is going to be equal to positive 3 root 3 over 5. Now we've not quite finished yet. We've got the gradient of the normal, but now we need to find the equation of that line. Now we can't do that until we know our x and y coordinates. So first of all, we need to find those by subbing in pi over 6 into x and y. So 3 sine of pi over 6, which is going to be equal to 3 sine shift pi over 6, which is equal to 3 over 2. So x is equal to 3 over 2. X is equal to 3 over 2. Y is equal to minus 5. Oops, not minus 5. Y is equal to 5 cos of pi over 6, which is 5 cos, open bracket, fraction button, shift pi over 6, close bracket. So that's equal to 5 root 3 over 2. So y is equal to 5 root 3 over 2. So now we've got our x coordinate, we've got our y coordinate, we've got our gradient, so we need to sub all of that equals into y equals mx plus c. So y equals mx plus c to find out what c is. So y is equal to this 5 root 3 over 2 is equal to m, which is 3 root 3 over 5 times by x, which is 3 over 2 plus the c. So let's do 3 root 5 over 2 minus fraction button 3 root 3 over 5 times by 3 over 2, which is equal to, c is equal to, so c is equal to 8 root 3 over 5. So if we write all this out, it's going to be y is equal to 3 root 3 over 5x plus 8 root 3 over 5. I'd probably times 3 by the 5 just to make sure it's nice. So 5y is equal to 3 root 3x plus 8 root 3 there, like so. Super. Tricky question that. Again, these questions are now just, it's not too difficult. I think it all makes sense. You're just doing the same things as you would normally, but we're differentiating our tan functions. We need to differentiate parametrically, so it's just bringing everything that we've already done together. Let's just have a quick look at that. They've factorized it out, but yeah, that's the same. Super. Okay, so we've got this question here. I'll zoom in a little bit so you can see it a little better. Have a little go at this question yourself. Have a little go at this question yourself. Okay, I can see this. We're starting to get there with this. So I'm going to start going through it just so I can, just so we can have a little go. So, if you are still struggling with it, sorry, if you're still working on it, then just keep going if you want. I'm going to start going through it now. So we've got x is equal to root 3 sine of 2t. We've got y, which is equal to 4 cos squared t. Now that's going to be the chain rule, just thinking about that already going ahead. Show that dy by dx is equal to k root 3 to t. So, this is worth 5 marks. So the first thing I'm going to have to do is differentiate differentiate x with respect to t. We know that we're subbing into this formula. Dy by dx is equal to dy by dt times by dt by dx. It's always worth writing that down to show the examiner what you've got, what you're doing. So, dx by dt is equal to, so remember, we can differentiate sine. Now, we've got sine 2t, so there's actually 2 layers here. We have to use the chain rule for this as well. So, let's write down our differentials for cos sine, cos minus sine, minus cos. So this one here, this root 3 to sine 2t. So if I differentiate the sine first, which is my inner layer, that's going to differentiate to cos. So it's going to be root 3 cos of 2t. Let's put that in a bracket just so I know. But then I'm also going to differentiate inside this, which is the 2t, and multiply by that. So times by 2. So I end up with here 2 root 3 cos of 2t. Now don't forget that actually I want the reciprocal of this. So dt by dx is equal to 1 over 2 root 3 cos of 2t. Okay, there's our first point. let's just put a line there so we know that these two are different. Let's differentiate this now. Now the first thing I'm going to do with this one is going to write it with the 2 outside, because actually we need to use the chain rule for this. So it's going to be 4 cos of t all squared. So the outermost layer of this one is that squared, the inner layer is that cos. So when I differentiate this with respect to t, I get dy by dt is equal to, so you bring the 2 down and take away 1 from the power, which is going to be 8 cos of t. Now the difference with this one is the 2's the outer layer, but inside that layer of the 2, we've also got cos. So we need to differentiate the cos and then multiply by that. Now cos differentiates to minus sign. So this is going to be equal to times by minus sine of t. Minus sine of t. So this is going to be equal to dy by dt is equal to minus 8 minus 8 minus 8 cos of t sine of t. Now, looking and thinking about this, the issue that I've got, the big issue that I've got, is that this is in terms of 2t, this is just in terms of t, and actually I want this in terms of tan 2t. So the issue I've got, and the thing you've got to spot, is that this one here on the right hand side, the one which is in terms of t, I can't use that one. I need to write this. I need to write this in terms of 2t. Now, you might be able to spot it here, because minus 8 cos t, minus 8 cos t sine t. Well, actually, I probably should write this like this, actually, shouldn't I? Minus 8 sine of t cos of t. Now, I've got to think about my rules with this one. I've actually got them up here, which is, I know that this here, I know this rule, which is that sine of 2t is equal to 2 sine of t cos of t. Now notice that these here look very similar. So this is where you've got to have a really strong understanding of your trigonometric identities, because actually I can now write this as, if I take the 2 out as a common factor, I end up with this, which is dy by dt is equal to minus 4 times by 2 sine of t cos of t, which is equal to minus 4. Now that 2 sine t cos t is the same as saying sine of 2t. So minus 4 sine of 2t there. So now I've got this in terms of 2t. Okay, then I need to substitute into that formula, this top one up here, which is dy by dx is equal to dy by dt times by dt by dx. So with this one here, I end up with dy by dx is equal to dy by dt, which is minus 4 sine of 2t times by dt by dx, which is equal to 1 over 2 root 3 cos of 2t. So this is equal to minus 4 sine of 2t all over 2 root 3 cos of 2t. Now I know that sine over cos is going to be tan. The only thing that I need to simplify is that minus 4 over root 3. So you're going to have to rationalise that root 3, but also you're going to have to cancel the 4 and the 2. Now, if you wanted to, and this is probably what I would do, I would just put that into my calculator to simplify it for me. So fraction button, negative 4 over 2 root 3, just because that rationalises it for me. I could work it out, but just for time and quickness. And that gives me 2 root 3 negative 2 over 3. Let's just write that down. So this gives me dy by dx is equal to negative 2 root 3 over 3 tan of 2t. So in which case, we've already got the root 3 in there, so our k is equal to minus 2 over 3. It's tough, that. The hard part of that is spotting that trig identity, isn't it? So that was worth 5 marks. We've still not actually finished here, have we? So we also need to do this second part. Let's just check the answer so we know. Yeah, minus 2 over 3. So find the equation of the tangent to this. So this is probably slightly easier. Now, notice that these two link, so you would struggle. You wouldn't get the full 9 marks on this unless you get this first part right, which is always worrying. So you need x and you need y first of all. So x is going to be equal to root 3 sine of 2 times by pi over 3, and y is equal to 4 cos of pi over 3. Now you can't do cos squared on your calculator, so you have to do it like this, all squared. So let's work out what both of these are. So root 3 times by sine of 2 times shift pi over 3, close bracket, is equal to, x is equal to 3 over 2. It's quite nice, isn't it? So x is equal to 3 over 2. Let's work out what y is. So 4 times cos of shift pi over 3, close that bracket, all squared, is equal to 1. That's quite nice as well. We're going to also need dy by dx, aren't we? Or the gradient of the tangent. So dy by dx is equal to minus 2 root 3 over 3 tan of 2 times by pi over 3, which is equal to, fraction button first, negative 2 root 3 over 3 times by tan of 2 times shift pi over 3, close bracket, is equal to 2. Nice again. Lovely to see it when it's a whole number. It doesn't always happen, but... So we've got this is equal to 2. Brilliant. So now we can just sub this in to y equals mx plus c, which gives us y is equal to 1, is equal to m, which is the gradient, which is 2, times by x, which is 3 over 2, which actually cancels again. Lovely there. Plus c, sorry, I should say. So we end up with 1 is equal to 3 plus c, which means that c is equal to negative 2. So in which case it's going to be y is equal to 2x minus 2. Look at that, nice at the end. All came good. Do like it when it... Hope that's right now. I'll give you a second to get that down. Let me just check it's right first, actually. Yeah, 2 minus. I do enjoy these questions. There we go. Y is equal to 2x minus 2. What a lovely little ending that is. Give you a second to get that down. Okay, let's move on from that then. So, we're now going to be having a look at implicit differentiation. Now, with implicit differentiation, you might want to write in your side title, which is implicit differentiation. We can differentiate everything with respect to x, but we don't have to differentiate in the form of y is equal to x of something. So usually, everything we differentiate at the moment is in this format. It's in y is equal to x squared plus e to the 2x minus cos of 2x squared. It's always something is equal to x or something is equal to t. But actually, we don't have to differentiate with these here. We don't have to differentiate this in this way. And this is called implicit differentiation. Okay? So we can differentiate things which are in the format of x squared plus y squared is equal to 8x. We can actually differentiate that. Or we can differentiate this. Cos of x plus y is equal to sine of y. So the way that we do this is we differentiate everything with respect to x. So when we look at this one here, we've got a mind-blowing moment here. So it says when we see y is equal to x squared and differentiating, you probably think you're differentiating the x squared, but in fact, you're differentiating both sides. You're actually differentiating both sides with respect to x. Now, you notice that since the start of year 12, I'll have already said that. But if we differentiate, if you look here at this part here where it says d by dx, the differential of y is the dy, the change in y, over the change in x. And then you're differentiating this with respect to x as well. So actually what we're doing here is we're actually differentiating the y with respect to x and then that x squared with respect to x. Okay? So to differentiate implicitly, you need to know two things. Differentiate each side of the equation using the chain rule as necessary. It's probably worth writing this down, actually, because these are key parts, okay? And remember that when you're differentiating y with respect to x, it is equal to dy by dx. Now, that is really important. I'll give you a second to get those down. Okay, so let's have a little look at some of these. Now, there's loads here. We've got, if you notice, we'll have loads of examples on this, but we're just going to have a look at this one first of all. Now, the first one, I'm going to add an extra one in here. Okay, I'm going to add a little extra one. I'm going to add, now you probably know this already, but I'm going to just add here d by dx of y. Now, if I differentiate y with respect to x, I end up with dy by dx. I reckon it's worth getting that down. Now, These next ones start to get a little bit trickier, okay? And these come up all the time, okay? So you need to get used to seeing these. So the thing is we need to use, we're using the chain rule for all of these. Now here, your two layers in this first one, your first layer in this one is that squared, and your next layer is that y. You can't just bring the two down now for that. Now that's a common mistake. Everybody will just differentiate that y with respect to x, but you can't. Sorry, that y with respect to y. But actually, we need to differentiate this with respect to x. So there's two layers here: the squared, and then that y inside it. Okay. So the way I differentiate this is I differentiate the squared first, which I know is 2y. And then I'm differentiating the y and multiplying by that. So that's times by dy by dx. So bring the 2 down, differentiate that, the outer layer, and then I'm differentiating the inner layer, which is the y. And y differentiates to dy by dx. This next one here, well, I know that if I've got my differentials, I'm going to differentiate sine and cos. It's these ones over here, which is, if I differentiate sine, that differentiates to cos. But don't forget, you've got two layers here. You've got the sine and you've got the y as well. So if I differentiate sine, I get cos of y. But I've also got to differentiate the y and multiply by that. So that's times by dy by dx. And I think you should start to kind of understand it now. This next one here, if I differentiate e to the y, I end up with e to the y. But then I've also got to differentiate inside that, which is the y, so times by. And I probably, if it was me, just to make it really clear, I'd probably put these in brackets. Or you could put the dy by dx in front of it. So e to the y differentiates to e to the y. Differentiating y differentiates to dy by dx. So you could, if you want to, write it like this: dy by dx, e to the x. Probably the better way to write it, but you wouldn't be wrong in writing any of those there. So these ones were the chain rule. We'll notice now with this one here is a little bit different. This one here, which is this one, is we've got two things which are multiplied together. So with this one here, we actually need to use the product rule. And we're going to say let u be equal to x, let y be equal to y, sorry, not y. Let u be equal to x and let v be equal to y. If I differentiate u with respect to x, I get 1. If I differentiate v with respect to x, I end up with dy by dx. And we know the formula for this is dy by dx is equal to u dv by dx plus v du by dx. So u is equal to x times by dv by dx, which is equal to dy by dx plus v, which is y, times by du by dx, which is equal to 1. So we've got to use here. Now these come up all the time, and you've got to be really confident with these. So here, when I differentiate this, you've got to use the product rule. I'm just going to make that really clear. And these ones here, over here, I need to use the chain rule. Now I'm going to start these in our next lesson. These ones here are where we get a little bit tricky. I'm going to start these in our next lesson. So let's have a little go at these then. Let's have a little go at these next ones. Now, these next ones are where we get quite tricky, actually. So I'm actually going to even give us some extra room on this. Okay, and I'm going to write these out separately because they're not just straightforward, these ones. There's definitely not enough space there. So my first one here is the differential of dx of e to the x squared y. Now, the reason this one's tricky is because we've got two things we've got to deal with. We've got the e to the power of x squared y. So there we've got the chain rule because we've got the two layers. We've got the e and we've got the x squared y. But also that x squared y is a product. So we've got to differentiate the e, which is going to be my innermost layer. But then I've also got to differentiate the outermost layer, which is the e. The inner layer is that x squared y. So I need to differentiate that as well. So if I write down here, u is equal to x squared, v is equal to y. I'm going to differentiate this first because I'm going to do all the differentials in a second. So du by dx is equal to 2x. dv by dx is equal to dy by dx. Okay, so then I'm going to sub it into dy by dx, which is equal to u dv by dx plus v du by dx, which is equal to u, which is x squared, times by dv by dx, which is dy by dx, plus v, which is y, times by du. Now I'm just going to go back a bit there, which is 2x, so that's going to be 2xy. So the differential, if I was differentiating with respect to x, x squared y, that's equal to this down here. Oops. So yeah, if I'm differentiating this here with respect to x, that's equal to this down here. Okay. Now, when I'm doing this, we've now got to think about the chain rule. So if I differentiate e to the x, I'm just going to get e to the x. So this is equal to, first of all, e to the x squared y. And then I've got to times by the differential of inside that, which is the differential of e to x squared y. Now I've already done that. That's over here, isn't it? So if I've got to times by x squared dy by dx plus 2xy there, like so. And you can take out an x if you want to as a common factor. So this is equal to x e to the 2x squared times by x dy by dx 2 plus 2y. So you could take that out if you wanted to. It's nasty that, isn't it? You've got to do the chain rule, you've got to think about the product rule. Okay, let's have a look at this next one, which is the differential of tan. I'm going to write it here first before we do it. So dy, oops, the differential of tan of x plus 1. So we've got two layers here, haven't we? Our first layer is that tan. Our inside layer is the x plus 1. So let's just draw a line under here so we know that these two are separate. So if I differentiate the tan of x plus y, well, if I differentiate tan, I get tan sec, is it? Sec x tan x? Sure, I need to get my just to make sure I'm not going to take any risks. Positive. if it's sec x tan x, but well, I'll have to go with it for now. So if I differentiate tan, where am I? If I differentiate tan, I get sec of x plus y, tan of x plus y, but then I also need to differentiate inside that and multiply by that, which is the x plus y. So I need to differentiate this, which is going to be, well, if I differentiate, now take note, this is x plus y, so it's not product now, so I can just differentiate these separately. Oh, made a mistake. The differential of tan is sec squared x. So actually, this is equal to sec squared of x plus y. Then I differentiate inside this, which is times by differential of x is 1, differential of y is dy by dx, like so. So if I differentiate tan, which is my outer layer first, which is going to be sec squared x, but remember it's sec squared of whatever's inside there, so x plus y, then differentiate the innermost layer, which is the x plus y. I'm just going to check that one. I just want to make sure I've got it right. Yeah, there it is. Sec squared x plus y. Sec squared x plus y. Yeah, so next one. And this is one more example. And take note, these will come up, okay? We will see these on the exam. So we've got the d by dx of x squared plus cos of y is equal to, now, we've got two things we need to differentiate here. We've got to differentiate this x squared, now it's plus cos y. So first thing I'm going to draw, I'm going to think about the fact that if I'm differentiating sine and cos, it's like this. So if I differentiate the x squared first, I end up with 2x. If I differentiate the cos y, now, because it's y, I've got to do the chain rule. So differentiate the cos first, which is going to be plus, well, cos differentiates to minus sine actually, so minus sine of y. But then I've got to differentiate inside that, which is going to be times by dy by dx. So this is equal to 2x minus dy by dx sine of y, like so. Lots going on there. Lots going on. Let's just check all those answers. There's all your answers if you want to have a look at them. I'll give you a second to get those down if you want. Okay, let's have a look then. Let's have a look at some trickier questions, the ones that come up. So, find dy by dx in terms of x and y of this one here. Oops. Now, first of all, I'm going to give myself some more room here. Or not. Just get rid of this for a sec. Okay. So find dy by dx in terms of x and y of this one here. So the first thing we need to do is differentiate this implicitly. So I'm going to write it down first of all. So it's x cubed plus x plus y cubed plus 3y is equal to 6. So I've got to differentiate all of these implicitly, and you'll get used to this. So the first thing we need to differentiate is this x cubed. So that we know what that is. We know that's just equal to 3x squared. Plus, if I differentiate x with respect to x, that's just equal to 1. Now these y cubes and y squareds are the ones which are a little bit trickier because we need to differentiate them using the chain rule. So the y cubed, you differentiate the cubed first, then you differentiate inside that and differentiate the y. So if I differentiate the cubed first, you bring the 3 down, so it's going to be 3y squared times by dy by dx, like so. And then plus, well, if I differentiate 3y, again, you've got to use the chain rule. Differentiate 3y, it'd just be 3. Differentiate then y, which is inside that, it'd be 3 dy by dx. And that one's quite straightforward. So this one's 3 dy by dx. And if I differentiate 6, which is just the number. Remember, 6 is a line which is across. It's 6 like that. That has got a gradient of 0. So this one here would differentiate to 0. Now, we've not finished this question because it says it wants dy by dx in terms of x and y. Now, to do that, what we need to do is we use rearranging the formula. So we take everything with a dy by dx onto one side, everything else onto the other side, and then we factorize and divide. So let's do that first of all. So 3x squared dy by dx plus 3 dy by dx is equal to minus 1 minus 3x squared. Then I'm going to take out dy by dx as a common factor. So dy by dx is equal to, no, it's not. Dy by dx times by 3y squared plus 3 is equal to minus 1 minus 3x squared. And then divide by all of this to get dy by dx on its own. So dy by dx is equal to, you can take the 3 out if you want, but I probably wouldn't, because remember we're trying to find out what dy by dx is. So you could take it out at the end, but you probably just wouldn't at this stage. So minus 1 minus 3x squared all over 3y squared plus 3. You could now take that 3 out if you wanted to. However, all they're asking for is dy by dx in terms of x and y. So that's why we've only taken the dy by dx out. Just give you a second to get that down. Let's have a look at this next one here then. So find the value of dy by dx at the point 1, 1, where we've got this one here. So let's get rid of all of these first. So first thing we've got to do is differentiate this with respect to x, okay? So let's do that first of all. So let's just write down what we've got. We've got e to the 2x ln y. Now that's an issue because we've got chain rule and product rule in there, is equal to x plus y minus 2. So the first thing I'm going to do, before I do anything here, is I'm going to differentiate that product rule there. So I'm going to do that over on this side. I'm going to say let u be equal to e to the 2x. Let v be equal to ln of y. So now when I differentiate this, I end up with du by dx is equal to, now if I differentiate this with respect to x, it's going to be equal to, well, e differentiates to e, so it's just going to be e to the 2x, but then I need to differentiate inside that, which is the 2x, which is going to be 2. So it's going to be 2e to the 2x. Differentiating this with respect to x, so v with respect to x. Now if I differentiate ln of something, that means it's 1 over that. So it's going to be 1 over y times by the differential inside that, which is, so if I differentiate y, which is dy by dx. Like so. Still not finished with this because I need to sub them into dy by dx is equal to u dv by dx plus v du by dx. So, with this one here, dy by dx is equal to u, which is the e to the 2x, times by dv by dx, which is 1 over y dy by dx, plus v, which is ln of y, times by du by dx, which is times by 2e to the 2x. Okay, it's nasty that there, and we do need to simplify. In fact, is it worth simplifying it now? Yes, it probably is. No, actually, I'm not going to simplify that just yet. But I tell you what I will do is I'll put the dy by dx in front and leave the 1 over. So here, I'm going to say this is equal to dy by dx of 2x, e to the 2x over y, I will do that, plus ln of y 2e to the 2x. Okay, so now I need to differentiate. I still haven't started thinking about differentiating this. So if I differentiate that left-hand side, I've just done that, and the differential of this is that part I've just worked out, which is dy by dx of e to the 2x over y plus ln y times by 2e to the 2x, like so. So that left-hand side I've already differentiated. If I differentiate the right-hand side, I'm going to end up with, well, differentiate x is going to be 1. Differentiate y is dy by dx. Differentiate minus 2, well, that's just a line across, down at minus 2, so that's going to be equal to 0. Brilliant. So, the next thing I need to do is to make dy by dx the subject. Now, I do that by taking everything over to one side, taking everything over to the other. Now, I probably would as well just simplify inside this. I'd probably write it in a slightly different way. I'd probably write 2e to the 2x ln y, but that's okay. So let's do that now. I'm going to take the dy by dx over to one side. I'm going to take the 1 back. So it's going to be 2e to the 2x ln of y. Bring the 1 over. Minus 1 is equal to, so keep that dy by dx there, dy by dx minus dy by dx times by e to the 2x over y. I probably would times through by y as well here. So that's going to be equal to 2y e to the 2x ln y minus y is equal to dy by dx minus dy by dx of e to the 2x. Let's just make that nice and clear to the examiner what I've done there and to everybody catching up. So I've times by y and times by y there. So I need to take dy by dx out as a common factor. So that's going to be 2y e to the 2x ln of y minus y is equal to dy by dx of 1 minus e to the 2x. I'm just going to put a line there so we know that this was done first. Okay. So we're nearly there now with this, because we're now going to divide by that 1 minus e to the 2x. So we end up with dy by dx is equal to 2y e to the 2y ln y minus y all over 1 minus e to the 2x. Have I finished there? No. Now what I need to do is I need to sub in 1 into this. Probably could have done that earlier to make this easier, but I wouldn't have done that. So I'm going to sub that straight into my calculator just to see what it is. So, fraction button first. 2 times by 1 shift e to the power of 2 times by 1, close that bracket, ln of 1 minus 1 all over 1 minus shift e to the 2 times 1. I'm just going to check that's right. Are they going to want the exact value for this? Probably. Annoying. Let's do it. They've given me as a calculator, as a 0 point something on here, so. No, that's a very good point. I've actually forgot there, haven't I? So when I times by y, I also need to times this by y as well. Which means that this is going to be equal to, there's going to be a y there, which means that this is going to be equal to y minus this. What happens if I change that? It's still 1. Which is very convenient, but so yeah, we're still gonna have to, it's still gonna be in that form. So I need to write this in terms of e to the 2. What is ln of 1? ln of 1, 0. That's nice. Okay. So let's sub everything in then. It's gonna want the exact value, isn't it? So let's do it. So 2 times 1 e to the 2 times 0 ln of 1 minus 1 all over 1 minus e to the 2 times 1. Now the thing that's nice about this is the fact that because ln1 is equal to 0, all of this part here is equal to 0. So you just end up with I'm just going to give myself a little bit more space here. Dy by dx is equal to the minus 1 here. So minus 1 over 1 minus e to the 2. Now I'm going to times both top and bottom by not e to the 2x. I'm going to keep going. So if I times both top and bottom by 1, I end up with by minus 1. So times by minus 1 times by minus 1, I end up with 1 over e to the 2 minus 1, like so. Just going to check that answer. Yeah, good. Somebody's trying to throw me off there, but I was right. Brilliant. It's hard, that question. Brilliant. Super. Difficult, that. Really tricky. Loads going on, isn't there? Okay, there's the answer for those two. So we've got 2 questions here. Have a little go at these to yourself. So make sure you're having a little go at these to yourself. So let's start having a go at these questions then. So the first part here says, so this is a past paper question. It came from C4, which is the old kind of like the advanced, kind of the back end, yeah, the trickier maths. So here it says, find the coordinates of the 2 point where x is equal to 8. So the first thing I've got to do is I've got to sub in when x is equal to -8 and find out what the 2 coordinates of y are. So when x is equal to -8, we're going to sub in, so it's going to be -8 all cubed minus 4y squared is equal to 12 times by -8 times by y. So that's going to be equal to brackets -8 all cubed is equal to -512. So -512 minus 4y squared. So 12 times by -8 is equal to -96. So that's equal to -96y. So let's take everything over, make it equal to 0. So 0 is equal to 4y squared minus 96y plus 512. Now if I want my two values for that, I need to type those straight into my calculator. Let's do that then. Where is it? Here we go. Polynomial degree 2, and I've got 4. I've got -96, and I've got 512, and that gives me two solutions, which are 8. So y is equal to 8, and y is equal to 16. Super. Find the gradient of the curve at each of these points. So next thing I need to do is to differentiate this and then sub in my 2 points, which are going to be, well, because x is equal to 8, my first point is going to be equal to -8, 8, and my next point is going to be -8, 16. So let's differentiate this first. So x cubed minus 4y squared is equal to 12xy. Now the one that's tricky is the 12xy because it's x times y. So I'm actually going to do this over here. Now whenever it's a product, I'd always suggest doing it on the side. Maybe even do it. Let's do it over here. So u is equal to 12x. V is equal to y. Du by dx is equal to 12. dv by dy is equal to dy by dx. So then u dv by dx plus v du by dx is equal to, u is 12x, so 12x dy by dx plus v, which is y, times 12, so 12y. Nice. Okay, so we've done that there now. Let's say note that this here is that differential of that. That's why I've done it on the side. So the differential of that part highlighted there is that. So let's do this now. So it's going to be 3x squared. It's the differential of that. Now I've got to use the chain rule for this one with the y. So I differentiate the 2. And then I got to differentiate inside that and times by the y. So with this one here, it's going to be minus 8y times by dy by dx is equal to the differential of 12xy is equal to that thing over there, which is just done. So 12x dy by dx plus 12y. Super. So now we need to take the dy by dx over and bring the 12y back. So we end up with 3x squared minus 12y is equal to 12x dy by dx plus 8y dy by dx. Now I'm going to take dy by dx out as a common factor and then divide by it. I'm going to do that all in one now. So 3x squared minus 12y all over 12x plus 8y is equal to dy by dx. So now what I need to do is I need to sub in both of those values for this, which is annoying. So let's sub in for minus 8. So minus 8 comma 8. Let's sub in for that first of all. So dy by dx is equal to 3 times by negative 8 all squared minus 12 times by 8 all over 12 times by minus 8 minus 8 times by 8. Let's work out what that is first. Fraction button. 3 times by negative 8, close the bracket, all squared, minus 12 times by 8, close the bracket, all over 12 times by negative 8, close bracket, minus 8 times by 8. So the first one is equal to, where have I gone? So the first one is equal to minus 3 over 5. We also need to sub in for minus 8 comma 16. So that's going to be dy by dx is equal to 3 times by negative 8 all squared minus 12 times by 16 this time all over 12 times by negative 8 minus 8 times by 16. I'm just changing that 8 on the right to 16. So 16 and 16 is equal to 0. Brilliant. Let's just check those answers. Minus 3 over 5 and 0. Check my differentiation. Minus 12. Good. Got a differential right, so 3x squared minus 12y 12x plus 8y. How have I typed that in wrong? I forgot. X equals 8, y equals... Gradient the curve each of these points. So we've got that. Minus 8, 16, minus 8, 8. We've got both of those, they're both right. We've got our differentials, they're right. I've got a feeling there must be wrong there. Must be. We've done everything right apart from the answers. I think that I can't see where I've gone wrong there. I've got everything that they've got apart from that final answer. I'm going to say that I'm right and they've made a mistake. Alright, so let's have a look at this next question then. Give myself a bit of space here. Okay. So I'll start this off, but we will have to carry this on next lesson probably. So find dy by dx in terms of x and y, give your answer in a simplified form. So x squared plus y squared plus 10x thank you, Sue spotted it. Silly. All of that hard work. I was trying to figure out where I'd gone wrong. So yeah, it's the plus 8 on the bottom, isn't it? And I put minus 8 for some reason. All of that hard work. And then you've got a positive and a negative wrong on the bottom. So in which case, this is going to be 0 and this is going to be 3. So this is equal to 0 and this is equal to 3. Minus 3. Thank you. Alright, I'm going to carry on with this question next lesson. Okay, I'm going to carry